Anything from 9.1, girls, that you need to look at today? Morning, Brendan.
Morning.
I'm just asking, is there anything from 9.1 that you want to look at? Because I'm going to do 9.2, and 9.2 is a biggie. So I want to know, and it's something that'll be brand new to you. So is there anything from 9.1 that you guys need to see this morning? No, we're all okay? Okay, let's look at page 305 then. So this is a big one today. It's a little bit new to you, so I'm going to do the best I can to explain it. I mean, in the times that we have here. Okay, so when you were doing a reciprocal function and you were in the form y equals a over x minus c plus d, the asymptote, the vertical asymptote occurred at x minus c, all right, equals 0. So you would draw your vertical asymptote at wherever x minus c was equal to 0. So x would equal c at that point. Now, what happens if we have, so all of these graphs are going to be done without the use of technology. So how do we graph more complicated graphs? So what we want to do is we want to find out, how do we show where asymptotes are? Okay, so we want horizontal asymptotes, we want the vertical asymptotes, and today we're going to learn about what we call a point of discontinuity. So basically what a point of discontinuity is it's a coordinate on the graph that it can't equal, all right? So you can't have a value for it. So normally we would say, well, that's an asymptote. But as it turns out, a point of discontinuity can be a coordinate in which you draw an open dot for it, okay? And it doesn't count towards the asymptote. It's drawn in there. So it says determining asymptotes of point of discontinuity. The graph of a rational function may have an asymptote, a point of discontinuity, or both. To establish these important characteristics of a graph, begin by factoring the numerator and denominator fully. Okay, so the first example they use is this one. So this actually goes back to 9.1. So we've got y equals x plus 4 over x minus 3. Now we can't have it, we want to attempt to get it into this form. That's our ideal form right there. That's what we want to get it into. So to do that, I'm going to go x minus 3 plus 3 add 4 all over x minus 3 over x minus 3. So that cancels, that leaves me with 1 plus 7 over x minus 3. Okay, so now I can graph that, and what I know is that for my C and my D, so my A, 7, my B, we don't work with B in the reciprocals. So C is 3 and D is 1. So that means that the intersection point, the intersection coordinate for my asymptotes now is at 3 and 1. So if I were to draw out this graph right now, I'd go 1, 2, 3 over and up 1, and I would have my asymptotes right here. So the equation of my asymptotes, what you need to know is on the bottom of the equation of the asymptote is x equals c. The equation of the horizontal asymptote is going to be y equals d. Pretty simple, right? So your vertical asymptote is at where x is equal to c, and your horizontal asymptote is at y equals d. All right? And it's like that for all of them, okay? So then we'd have to put in our coordinate here and a coordinate down here, wherever it is, cross them, draw them like that, and whatever, okay? So we should be a little more specific. The 1 and 1 would move to 1 and 7, and then we move it right 3 and then up 1, so whatever that works out to. But all I want to focus on right now is my equations of my asymptotes. So in this graph, all right, I ended up with that as my equation, and my asymptotes ended up being x equals c, y equals d. Okay? There are no common factors here. All right? And I have to point that out, because what we're going to do is we're going to get into graphing a little bit more complex graphs, and we have to find out if there are any common factors, because if there's common factors, this leads to this point of discontinuity. So that first example on page 305 is where you have asymptotes and no common factors. So this is exactly what we did in 9.1. So far, just review. We're okay at this point. Now we got to get into a little bit more complex graph. So I have the equation . All right, so the first thing that I see, okay, the first thing that I see is I'm going to have a vertical asymptote, or should have a vertical asymptote, I would think, at x equals -2. But if you look at this equation closer, because I factored the numerator and I factored the denominator, I have a common factor on the top and the bottom. So what happens here is this, is these guys would actually cancel out, and I would be left with y equals the graph of x subtract 4. So I don't have an asymptote because I don't have a reciprocal function here, or a rational function. So all I would do then is graph y equals x subtract 4, 1, 2, 3, 4 down here. 1, 2, 3, 4 right here. And I would graph it like this. Pretty straightforward. But I can't ignore what happened right here. So because I have a common factor on the top and on the bottom, that means I have what we refer to as a point of discontinuity. And that point of discontinuity occurs where x is equal to -2. So my point of discontinuity is at x equals -2. So I want to find out what the y value is where x is equal to -2. So I'm going to substitute it into here. Y equals -2, subtract 4, which equals to -6. So I go to 1, down to here. Oh, I don't want to do this. And I open a dot right here. So I have the graph of the line y equals x subtract 4. And at the point where I have x is equal to -2, I draw an open dot at x equals -2 and -6. And that is what we call our point of discontinuity. So if you were to graph this on a calculator, so I'm going to do that over here. So let me fix this up a bit here. All right, so I'm not sure how well you can see this. Here's my line right here. And at -2 and -6 down here, I have an open dot. So if I go down to it, it actually says on here -2, -6, and there's a hole where y equals x minus 4, x plus 2, x plus 2. So what that means is it cannot include that coordinate of -2 and -6. All right, that's what we call point of discontinuity. So we're going to break down these graphs, and we are going to have asymptotes or points of discontinuity or both. Okay, so this is an example of having just one point of discontinuity with no asymptotes for the graph. All right. So like I said, this is new to us. Okay, so we are still trying to graph these equations. All right, so let's look at one where I have both occur. Okay, so this is example, this is the bottom of the page 305. So I have the following equation, y x minus 4 and again, they'll be factorable. They'll all be factorable, so if they give them to you as a quadratic, you can break it down. So looking at this right now, if I have a factor on top and a factor on the bottom, those leave me with a point of discontinuity. So I just want to make a note of that. So my point of discontinuity is x equals -2. So it happens to be the same in this question. Break it down, I have x minus 4 over x minus 1. Still can't graph that in the form that it's in. So x minus 1 plus 1 subtract 4 over x minus 1 over x minus 1 equals 1 subtract 3 over x minus 1. So that means that my a value is a -3, my c value is a 1, and my d value is a 1. So now I have two asymptotes and a point of discontinuity. So if I were to graph this out now, first thing I notice is at 1 and 1, I have asymptotes. Right there. Okay? So the next thing that I have to do is I'm going to follow my two coordinates. So 1 and 1, and -1 and -1. I'm going to follow those along. So because of A, this becomes 1 and -3. This becomes -1 and +3. Move them both right 1. 2 and -3. 0 and 3. And then move them up 1. Okay, so I have a coordinate of 2 and -2. And 0 and 4. So let's mark those in. So 2 and -2. That's 1. Here's 2. That's down here. Okay. And then my other one is 0 and 4. 1, 2, 3, 4 is right here. Okay. Now I draw my shaped graph like this, but I have to remember at x equaling -2, I have a point of discontinuity. So again, I'm going to plug it into here. So I'm going to use this equation right here. I'm going to plug it in. -2 subtract 4 over -2 subtract 1. So -2 subtract 4 is -6 over -3, which gives me 2. So at 2, -2, 1, 2, and right here, I draw in my hole, which is my point of discontinuity. So at -2 and 2 is my point of discontinuity, so I draw an open dot on the graph. Now I have two asymptotes. Asymptote 1 is x equals 1. Asymptote 2 is y equals 1. And my point of discontinuity is -2 and 2. So where you have a point of discontinuity is when you have a factor on the top and bottom that are exactly the same. All right? Okay, let's look at example 1 on page 306. All right, so I've got f of x equals. I'm going to factor this. So you're looking at a fairly complicated question in order to graph it, right? And so what I'm going to do then is I look at it and I say, okay, well, I have a factor on the top and a factor on the bottom that's the same. So we cancel those out. My point of discontinuity is going to be at x equaling 4. My new graph is the graph of x plus 1. So I graph a line. 1, up 1, right 1. Got that there. 1, 2, 3, 4. Okay, and now I got to put my x value in to find out what my y value is at my point of discontinuity. So it's 5. So at 4 and 5, 1, 2, 3, 4, and 5 is up here. I put an open dot right there. So it really isn't that difficult of a task to do. Okay? You've got 4 and 5. I add my open dot, and that's all it is. So when it comes to the point of discontinuity with no asymptotes, all you're generally doing is drawing a line. And then you put an open dot somewhere along that line. Okay? Let's look at example 2. It says compare the two graphs. Compare points of discontinuity and asymptotes in rational functions. All right, so again, let's factor both of these graphs. So I've got x plus 3, x plus 1 over x plus 1. So my point of discontinuity is going to be at -1. On the second graph, I have g of x equals x minus 3, x minus 1. Is that right? Okay, so I have x minus 3, x minus 1. And in this one, I don't have a common factor, so I have no point of discontinuity. I am going to have an asymptote at x equaling -1, and I can very easily graph that. So it says with the help of technology, they want you to graph it. So the first one I'll graph. So my graph is now f of x equals x plus 3. I have a point of discontinuity at -1 and 2. So I go to 0 and 3. Up 1, right 1, over to here. Graph my line, and then I go to -1 and 2. And there it is there. So that's the first graph of f of x. So that one we can do without technology. All right, all we're doing is graphing a line here. Now, this guy, use your calculator for it. Punch it in, graph it. I'll graph it just for the heck of it. But so it was -3 -1. We're +1. So it's a goofy looking graph like that. No points of discontinuity. Again, you probably can't see that very well because of the glare. But not something that you need to be able to graph without technology. All right, and they're not going to do that too many times. So they were just asking an example too. Can you figure out or decipher whether or not there's a point of discontinuity or not? Okay, so the last one, example 3, is point of discontinuity and 2 asymptotes. So let's have a look at it. Let's go through the whole process again. Okay, so the first thing I do is I factor out my equation. So I've got x squared plus 4. So x plus 4, x minus 2. Then I've got x plus 4, x plus 1. I know my point of discontinuity is going to be at -4. Cancel those. I've got x minus 2 over x plus 1. Rewrite that equation out. X plus 1 minus 1 subtract 2 over x add 1. X add 1. That leaves me with 1 minus 3 over x plus 1. So, first things first, point of discontinuity. Put -4 in here. That's -6 over -3. So that would be -4 and 2. Okay. My A value, -3. My C value, -1. D value is 1. Asymptotes fall at -1 and +1. Okay, then what you would do is you would find out where your ones and your 1 and 1 and your 1 and -1 and -1 end up. Okay, so that would be 1, -3, -1 and 3. Move it. 0, -3, -2 and 3. And then up 1, so that would be, sorry, I'm cramming, 0, -2, and -2 and 4. So I go to -2 and 4, right there. I go to 0 and -2, right here. And then I have to go to -4 and 2, which should be about there, and draw my point of discontinuity in. Okay, so it looks pretty easy, but there is a lot of work here to do this. Okay, so let's go through it again. First things first is you factor. You factor and you cancel out the terms that are the same. So then I have x minus 2 over x plus 1. All right? So that's the graph that I've got to do. I've got to do x minus 2 over x plus 1. So I add 1 and subtract 1 so that I can cancel my denominator out. So I'm left with that equation right there, which is a over x minus c plus d. I write down what my a, c, and d is, as well as my point of discontinuity. Okay? I follow my 1 and 1 and -1 and -1. Follow them through their transformations, because those are the 3 key points. So I've got point 1, point 2, point 3, and then point 4 is your point of discontinuity. All right? So that basically does all of your transformations and everything with it as you're working through there.
Mr. Newton.
Yeah.
So over on the left-hand side where it's like x minus 2, x plus 1.
Yes.
Do you mind going back? Like how did you get the x plus 1?
Okay.
X?
So this is what happened last week. What I need to do is I need to add and subtract something to this so that I can cancel out with the denominator on the bottom. So basically what I do is whatever this coefficient is times this is what I'm going to add to it. That's how that works. So I'm going to add a 1 to that x, put it over top of x plus 1, and since I added 1 to it, I have to subtract 1 over here to keep it the same. And so that puts this over x plus 1. So what I'm doing is x plus 1 subtract 1. All right, now why I do that is then this and this will cancel and leave me with 1. And now I've got minus 3 over x plus 1. So you... Okay, so you didn't do any of 9.1 then?
No.
Okay, well, yes, you need to. We are going to get through this. So we got to get moving on this course. We still got 10 and 11 to do yet. Okay? So that's how I end up here, which is in the rational form of a over x minus c plus d. Okay? Any other questions this morning about this point of discontinuity? So basically, it's 9.1 is the same. We've just added some algebra in there. This part right here has been added to what you already did. From here, you're graphing the same way as you did in 9.1. So you needed to be able to do 9.1. We did this in applied as well. So this part shouldn't be new to you, other than you're not using your technology right away. Okay? All right, so what you need to have done for tomorrow is page 309. Just get done 309, and then you can work tomorrow on finishing the rest of 9.2. But those of you that aren't done to the end of 9.1, you got to get this done. I can't slow up anymore. We've only got a few weeks left. I want to get this course done as soon as we can. Okay. All right. Any questions, comments, concerns about 9.1 or 9.2? So Wednesday, sorry, you can expect to go through 9.3 on connecting this. And same as we've always done is you always start with the graphing aspect of it, and then we got to find out where these things connect using equals and equations. Okay? All right, anything from 9.1 and 9.2? Now's the time to ask. All right, so you need to have 309 done. Get done page 309. I'm going to start a new stream here on YouTube.